Earth. As far as we know, it's the only home to life in the universe. So what makes our planet so special? To find answers, we must travel back in time. See the first humans walk the Earth. Ride each colliding continent. Face killer dinosaurs. Dive into global ice ages. And experience the fury of cosmic missile attacks. By traveling back in time, we can piece together our planet's incredible story and discover why all of this and all of us are here. The journey starts almost 5 billion years ago. There's no sign of Earth just yet. Only the sun, a newborn star surrounded by dust. The Earth hasn't formed yet. But through time, gravity pulls the dust into tiny rocks. To our surprise, something as complex as a planet is made from nothing more than dust and rocks. Over millions of years, gravity pulls these rocks together to form one of at least 100 planets circling the sun. But 4.5 billion years ago, Earth looks more like hell than home. Up close, the temperature is over 2,000 degrees Fahrenheit. There's no air, just carbon dioxide, nitrogen, and water vapor. It's so hot and toxic that if we got any closer, we'd be incinerated and suffocated in seconds. This newborn planet is a boiling ball of liquid rock. An endless ocean of lava. A young planet called Theia is heading straight for Earth. The size of Mars, it travels nearly 10 miles per second, 20 times faster than a bullet. The intruder's gravity distorts the Earth's surface. last wave races around the planet. It's as though both young planets turn to liquid. Trillions of tons of debris blast out into space. But over the course of 1,000 years, gravity turns the rubble into a ring of red-hot dust and rock that circles the Earth. From this ring, a ball forms, over 2,000 miles wide. It's the birth of our moon. But it's much closer than the moon today. Just 14,000 miles away, instead of 250,000 miles. The sun rises over a cooling Earth and sets just 3 hours later. The Earth is spinning so fast that an entire day lasts 6 hours. The days may pass quickly, but the Earth changes slowly. To understand the making of our planet, we need to fast forward through millions of years. $3.9 billion years ago, a hail of meteors attacked the Earth. It's debris left over from the solar system's formation. Inside the meteors are crystals that look like grains of salt. And inside the crystals are minute droplets of water. These deadly missiles could contain the vital ingredient for life on Earth. Only a small amount of water exists inside each meteorite. But as they bombard the Earth for over 20 million years, pools of water grow. The Earth's core remains molten, but its surface has cooled enough to form a crust. The air is around 170 degrees. In the future, there's a chance we could swallow this very water. Every sip, every puddle, every drop of water in every ocean is billions of years old. And it may have traveled millions of miles to reach us, carried inside a meteor. The Earth looks more familiar, but it's still a dangerous place. Winds are faster than the most destructive hurricanes today. It's a megastorm, whipped up by the planet's rapid rotation. The moon is so close to Earth that its gravity is overwhelmed, creating huge tides that race across the planet's surface. But over time, the moon moves away, the waves calm down, and the planet spins slower. "700 million years after the planet's birth, life-giving water covers its surface. And scattered throughout are tiny islands. They seem to have appeared from nowhere. So how did they get here? Molten rock bursts through the Earth's crust and rises up through the ocean. Over time, the lava cools, forming a volcanic island. In the future, these islands will join together to form the first continents. Earth now has water and land. It's beginning to look like the planet we call home. But the atmosphere is still toxic, and the temperature is scorching. Life here is impossible. Since the planet's formation, meteors have been pummeling Earth. But now, 3.8 billion years ago, the assault enters a violent new phase. Some things disturb the orbits of these meteorites. In addition to water, the meteors carry something else. As they dissolve, the meteorites release minerals. Carbon and primitive proteins made of amino acids are transported from outer space to the bottom of the ocean. Thousands of feet below the waves, it is dark and close to freezing. But a dramatic illusion is taking shape. Underwater chimneys spewing hot liquid. Seawater seeps down into the earth through cracks in the crust, collecting minerals and gases along the way. This potent mixture is released back out into the ocean, building these towers.